Well, we predicted an earthquake uptick starting on or before February 18th, and we're seeing an uptick now. So, does this mean that our theory of where this brown dwarf is wrong because our earthquakes have shifted? Or is there something else at play? The first thing you notice in front of you is in Montana, we're seeing unprecedented volcanic activity. Most of these are shallow quakes, less than 10 kilometers. Some of them are at like a negative depth, which puts them at elevation, meaning they're happening, the tremors are happening in the mountains. You see like a Y shape coming out into the southern Montana. That Y kind of curves down into where? Yellowstone. The overall vertical topography of that entire region, you notice, is very patterned, well-defined patterns, and we'll come back to this whole region. Going on in central Idaho, this has been going on for a long time. So when you take into consideration how long it's been happening, this is unprecedented too. So you have areas next to Yellowstone that are behaving like volcanic activity, similar to volcanic activity, and near Yellowstone. This is a map of Montana, and you see here hot springs. In Montana, you see that Y shape coming out of Yellowstone, where that very bottom, almost southernmost decal is. That's going into northwest Wyoming. So again, you see that Y shape coming out of there, and all of these are hot springs. So if it's not volcanic, why are there hot springs everywhere where there's earthquakes? This is a completely separate map of these hot springs in Montana. And then of course down at the lower right, well actually of Montana, but right central to this screen is Yellowstone. And so you can see the hot springs making a Y, and again, our earthquakes are mimicking that placement. You pull out a little further, and this is the Y looks a little elongated. You can see it goes all the way from Yellowstone up into Canada. But that whole region, that's a massive area that's very well patterned and extremely seismically active. And in Idaho, you're going to see almost as much hot springs, as many hot springs, as you do see in Montana. So imagine that whole area you're looking at right now being a giant mega super caldera. And then imagine lava flows building really high plateaus, thousands of feet high, and then subsequent glaciation carving using gravity and slope with the new glaciation. Short-term new glaciation is extremely erosive because it happens in a short period of time, and that causes flows that are fast-moving glaciers, creating a lot of gouging and seeing a lot of ice fracturing. We go over to Mammoth Mountain, another super caldera on the rim of the Great Basin, of one of these basins, and you see that ring around. That ring is literally surrounding an uprising dome. There's a central thumb to this caldera that has risen. It's a little higher than the valley floor, and it's long. It's you're looking at 4 or 5 miles. That kind of a dome, and you have activity all around that dome. That tells me either subsidence or uplift is happening. We pull back and go at all the smaller earthquakes in Southern California, and we see along the San Andreas, we see the volcanic-like clustering. Up towards the central California, you see the Ridgecrest stuff going on. Once Ridgecrest started, it never stopped. At the top of the screen in blue, we see new activity in Nevada. That's those quake clusters near Hawthorne that are due east, straight due east of a very, very large crater or caldera called Inyo or Mono Valley. And then due south, right there, is Mammoth Lakes. So you're seeing tectonics mixed with volcanic related seismicity. And the volcanic seismicity is easier to tell because you get less clear margins on your earthquakes. Well, here's the cluster, and it's more regional right now. So this is just north of Australia, and we have Sumatra rocking in the lower left. Those are low 6-pointers, all of them not very deep, and the one off of Sumatra is near what? A supervolcano. You go over to the right of the screen, you see Papua New Guinea. New Guinea is infamous for its volcanoes. We've covered how every volcano around there has gone from intermittent to ongoing, and very explosive eruptions. Then our other 6-pointer, the bottom right of the triangle, is down due west of New Caledonia, and that's about as far as that trench can go south. So we've had 3 earthquake clusters of 6-pointers in just a matter of a few days. So it looks like it could be something else going on, because the large body alignments generally push 7.0. They affect the mid-Atlantic ridge and the subsidence zones, all of them, just like other alignments do. And the relationship between seismicity and alignments, connecting the dots, what's causing what, can be a nice philosophical discussion, and I do think there's evidence that people are ignoring. Our position of this brown dwarf is out beyond the orbit of Uranus now, but in this general direction. We take a 90-degree alignment with that position, and we see the sun does not fall into alignment with Earth, but Mercury did pass through. And when we do a 90-degree off of that alignment, there's Mars sitting at a direct 90 degrees to Earth and the sun and Mercury. Now, Mars is not generally noticeably and significantly geo-effective on its own. It does require other planets to help it out. And when Mercury gets on the same side of the sun as Mars and Earth, we can see clustering of very short-lived but slower and lower magnitude. And so that's probably what you're seeing is this alignment right now. It's happening right now. But when Earth falls into 90 degrees with that brown dwarf, we're going to push 7-pointers. And we're warming it up right now with the Mercury passing. Now, there's a reason that we're not showing the Mercury transit. I can't imagine. It has to be maybe with the inclination, declination, or Mercury's changes in orbit. It probably does not match what the ephemeris would say. And these ephemerises or ephemerises need to be updated. And these things were supposed to be as rigid as a clock, but now they're being updated because the solar system's changing. And that's all documented. And there's only one plausible, real, simple explanation. There's an object in the solar system. Now, people think it should be bright like the sun, but it's a brown dwarf. It's not even visible to the naked eye because it emits a lot of its energy in infrared. But coming back to the earthquakes, when we fall into a 90-degree alignment, we have to understand that all magnetic and gravitational fields are strongest when an object passes 90 degrees to the direction of that field or the flow of that field. And when we look at the entire northern basin, we see that there's intrusions of mountains. The Bitterroot is especially The Bitterroot mountain range is especially prevalent in Idaho going into Canada. But look at those cuts, the pattern. And then in the upper right-hand corner, you have another basin. You have Wyoming in a basin. And all along here, we're seeing hot springs, volcanism, volcanic mountains, glaciated erosion to those mesas and mountains, ice fracturing to those mountains. But the rivers always want to flow where? To the bottom of your caldera. And even if it's a massive, super, mega, giant caldera called the Northwest United States, you can get intrusions and mini volcanoes inside your super calderas. You can get calderas within your calderas. You can get mountains within your calderas, because the whole southwest part of Mammoth Mountain caldera is infiltrated with mountains, the Sierra Nevada, parts of the Sierra Nevada. But so this area that's encapsulated here, that encapsulates the hot springs, all prevalent in this area, you have to assume that the origins of this whole area owes its topography to what's lying underneath the soil. And that is massive amount of magma, about 1/5 of what lies in the entire Pacific. And that's why we think we see extinctions of our native people. So yes, cyclic eruptions of all around the Great Basin, the Northern Basin, and this huge area I had encircled could be the reason we have so many native people go extinct. Now, if the brown dwarf was off to the right, 90 degrees, and up about 30 degrees, you would expect the neutral particles to be focused in gravitationally. Not has anything to do with magnetism, because they're neutral. But then you look at the corona of the sun, and you can see upper left portion of the disk has the brightest white in the image, and the highest density, and the greatest bulk of white coming off that, looks like 10 o'clock position of that disk. That's where the majority of the particles should be concentrated. When ejected out the other side, we should see a nice focusing cone. And that's what we see. We don't see it that perfect shape on the right-hand side of the sun when we're downstream and coming right at us. So if that brown dwarf was off to the left and slightly up, this is pretty much what you would expect a neutral particle focusing cone to look like. And you notice on the left-hand side, out further in the corona, you see some crisscrossing lines. And that, again, that's to be expected with a broad field of particles being focused. And then we look at the sun itself. If the brown dwarf was 90 degrees off to the left, then what's facing you right now is going to be experiencing the fastest solar wind and the inner corona. It's just like being on top of a mountain, on top of a ridge. That's where the wind is the highest speed. When you get to the top of the mountain, it's much windier than the side of the mountain. So basically, what's looking at you directly right now is simply the part of the sun experiencing the fastest speed to that neutral wind. That is why you see filaments all taking shape in the same diagonal and the same kind of shape. It's like wind blowing over water. It pushes the water up into a ridge. Only in this case, you have some high density stuff. The filaments you see running almost the entire length of the sun all conform basically to a wind pattern coming from the upper left headed towards the lower right. And when we put this stuff into motion, you can see the just the general disturbance, like there's a high wind causing disruptions and shifting in the surface plasma that's pointing directly at you. And you notice the plasma becomes extremely agitated when it gets to that position where it's pointing directly at you. The triangle shape of the coronal hole, it doesn't look like a hole, it looks like a triangle, doesn't it? Well, we've got theories to explain why we get triangles both in the north and the south coronal holes. But with that pattern of the filaments are almost matching kind of what we're seeing in terms of the focusing cone being illuminated. What causes white light is when the helium loses electrons, or when the helium runs into other particles. That creates visible light. The other factor is just neutral gas being awash with electrons lights up just like a neon light or an argon light. Is there such a thing? And so, yeah, with the electrons and the neutral gas, you're almost certain to get visible light. But also other wavelengths due to collisions that are higher, more energetic. Also creates X-rays. And we were seeing so many redacted files the last couple days on the telescopes and the satellites. We didn't know what was going on, but then we saw this really bright flash on the 9th. Maybe we were thinking that's why there's so many redacted edits on the 9th, because of that flash. Were there more comets? Was the transit of Mercury, was there something funky on it that they can't explain? I've been looking for the transit of Mercury on these satellites, and right when it's supposed to be transiting, we don't see images. They're gone. Our website is experiencing technical difficulties. So when we examine this really bright flash that happened on the 9th of February, it affected the upper half portion of the sun. Did it get so saturated in particles and in electrons that it let go a cascade, almost like a flash of lightning, only this time it's sheet lightning? I don't know. But if it was an anomaly of the photograph itself, you would think it would affect the entire frame and not just the upper half of the frame, which is doing there. So I don't know. We look at the X-rays and we do see a spike right about that same time. But that spike, it mimics a very, very small solar flare, and we see a massive, massive discharge or a flash in the northern corona of the sun. You would expect a spiking of the irradiance to be much higher. Also, on the 15th, we had a comet hit the sun right before the double comet hit the sun on the 18th. I went back to find that. It's been taken down. Why would they have such a problem with a small comet hitting the sun? Why would they be redacting files after the double comets hit the sun? We're seeing missing frames after these comets, and even the comets themselves being removed from the images. So that tells me we probably had 3 or 4 more comets hitting the sun than they've let on. That would create a lot of discussion and a lot of innuendo and a lot of conspiracy theory. So it's just easier to have technical difficulties. So in closing, this mountain range that I have encased in here, you can see the patterns, the tiger stripe patterns to the topography. It looks like very, very consistent erosion happened at one point in time. That whole Bitterroot Range disguises a much more massive caldera that extends from the Sierra Nevada all the way over to the Montana and Wyoming valleys. It also extends southward into the Great Basin and into the southwest. That would be a massive, massive caldera, and believe me, there's been sonic and X-ray topography taken of this area, and it's loaded what they call liquid carbon. Now you tell me how there's carbon liquid. But what gives it away too is all the hot springs, especially the ones in Montana that kind of follow what? That line of earthquakes. So if you want to try to tell me that the earthquakes happening in Montana are tectonic, I'm going to tell you they're volcanic, and that the entire rim of these basins are going to be active because that's where volcanoes have the greatest intrusions and changes in elevation, is that transition zone. Now that the parentheses down there in the lower right, that's Yellowstone. That's the Yellowstone caldera. So you see a lot of this stuff branching out from that whole area, which at one point in time must have been a massive magma chamber. So what we think is happening is these valleys are still subsiding and pushing magma out to the rims into shallower chambers. We're seeing intrusions up to 4 kilometers in Yellowstone, 2 kilometers depth. That's pretty shallow. And yet we're seeing the basin subside. So you press on the middle of a toothpaste tube, you create an indentation, but yet the toothpaste pushes out towards the ends of the tube. So magma's the same way. You push down on a magma chamber, you're going to shove the magma to the edges of your caldera, and in this case, a massive caldera extending all the way across the entire western United States. So if you were trying to portray the entire western United States, the Great Basin, the Northern Basin, as a super mega caldera, possibly even extending past into the Appalachians, but you can surely see remnants of calderas in the mountain topographical areas. Especially in Montana, you can see very narrow, some of the most narrow mountain ranges you'll ever see. They look like tiger stripes, but you can see round circular topography in amongst the mountain ranges, and that's always where? At the edge of the mountain ranges. So you could really paint a picture that this whole area used to be one giant valley, and through the epochs of volcanism deposited these really very high and layered plateaus, all the while subsiding a shallow ocean. And eventually you have left valleys that have sunk and mountains that have been layered, and then the erosion takes place. And that's going to happen if you have that kind of volcanism. You're going to have that kind of ice age. And so locally you may have hot lava, but globally you have cold ice age. The position of Mercury, I haven't got up and to look at it. I will be doing so now. If you have any or know of any links to show this transit of Mercury and this happened this past week, if you find any video, know a link, please attach it. I'd like to see the transit of Mercury. But by now, if it's a late post by the official source of those posts, then you have to wonder if the actual trajectory of that orbit has been technically modified. Anyways, so, and that flash on the sun, I can't say if it's real or not. We do see and have seen flashes on the sun that were picked up on the Earth and in the ISS at the exact same time. So when you have a camera on the ISS and you have a CCTV in Acapulco, and they both pick up this massive green flash in the sky, you can assume that that's not a coincidence. So, but anybody know of a major flash happening on planet Earth in the sky on the 9th? Please let me know. Okay, be prepared.